right, so what are we working on today? We're going to work on, again, finding a polygon of constraints, so graphing all of these inequalities on the same graph and finding what that area is that they all have in common that solves all of these inequalities. And in addition to that, we're actually going to start working on finding the coordinates of the vertices. So that means figuring out all of the intersection points between the various boundary lines for these inequalities. First thing we're going to notice for our constraints here, for these constraints, and again, I always do that. All right, for these constraints here, there we go. What I notice right away is that those two look sort of like my non-negative constraints, except my non-negative constraints are y is greater than or equal to 0 and x is greater than or equal to 0. However, there is an important piece of information that I can get from these two, and that is that my graph is only going to be in the first quadrant. How can I tell that? Because y is greater than or equal to 1 means all the y's are positive values greater than 1, and x is greater than or equal to 0 means all of the x's are positive values greater than 0. Okay, so all positive values. So everything needs to be in the first quadrant. That's useful to know because we want to graph the least amount of area possible. We don't want to have a whole bunch of extra space taken up on our page when we could focus just on the first quadrant. And there goes the bell in the background. We're probably going to have lots of noise in the background for now, but I'm going to keep going. I'm actually going to take this first inequality and do a table of values because I know a lot of people in this group are graphing using a table of values, so let's try using that method for a change. I'm going to pretend that this is y is equal to negative 4x plus 8. That's my boundary line. And I'm going to fill in some x and y values for that point. So if x is 0, it's negative 4 times 0 plus 8. So we end up with x is 0, y is 8. If x is 1, we have negative 4 times 1 plus 8. And that gives us a value of 4. So when x is 1, y is 4. And then for 2, we have negative 4 times 2 plus 8. And that is equal to 0. So that's 3 points right there. For our other inequality, for this one here, I'm going to do everything in red. So I have 4y is less than or equal to negative 3x, plus 24. I'm going to do a little bit of rearranging here. We're going to divide every single term by 4. And that will simplify to y is less than or equal to negative 3 over 4x plus 6. If I make a table of values for this, I'm pretending that my y is equal to negative 3 over 4x plus 6. Oops, I have this backwards here. Let's try that again. I'm going to put my x and then my y. Choose a couple of x values, so let's go with x is 0 because that's always a good one. Negative 3 over 4 times 0 plus 6, well that just ends up being 6. When x is, and this is where we want to be very careful. If I choose 1, I'm going to end up with a fraction and have to do all kind of estimating on my graph. I would actually rather go with a multiple of 4 because what ends up happening, if x is 4, I get negative 3 over 4 times 4 plus 6. What ends up happening there? Well, I've got 4 over 4, and that cancels. And I'm left with negative 3 plus 6, and I end up with 3. So now we have all of our tables of values created. We know that this line right here is going to be a horizontal line at y equals 1. We know this line right here is going to be a vertical line at x equals 0. So let's take a look at that and see what we have. You guys can go ahead and try doing your graphing. I'm going to cheat a little bit and jump ahead because I've already made the graph. So what do we end up with when we graph all of these? These are our inequalities all represented together. Okay, so they're all in the same graph. And this yellow shaded area is our polygon of constraints. So you can see here that I've actually added labeling to each of my inequalities. So the inequality here, and I'm going to attempt, oh no, I always do that. Why do I always do that? Okay, let me try that again. My inequality here, without moving my graph, is my y is greater than or equal to negative 4x plus 8. Okay? My other Sorry about that. The announcements always come on. My other inequality here is 4y is less than or equal to negative 3x plus 24. And then my flat line here, my horizontal line here, is y is greater than or equal to 1. And then the x greater than or equal to 0 is just this line here. But as you can see, it doesn't really change the appearance of our polygon. Okay, so it doesn't become a vertex on our polygon. So now our second goal, our part B, was actually to find the location of our vertices. And you can see here that I was exceptionally annoying, and I picked four inequalities that line up so that none of the vertices fall on an even point. And boy, is that annoying, but we know how to solve this because we are used to working with solving systems of equalities. So what I'm going to do here is actually give a little name to each of my vertices. So I'm going to call them A, B, and C. And what I want to do is actually figure out where A, B, and C are. I want an exact location. So first thing I'm going to think about, A is the intersection between what two lines? Well, it's the intersection between y is equal to, that's the equation of my boundary line, negative 4x plus 8, and 4y is less than or equal to, oops, why did I do that, is equal to, because it's a boundary line, is equal to negative 3x plus 24. Those are the two lines that meet at my vertex A. So if I have two lines that are meeting and I can't see very clearly on the graph what their intersection point is and I want to solve for it, I would solve it using algebra, solving a system of equalities. And we all know how to do this. We reviewed this in class. We know our three methods. We have comparison, we have substitution, and we have elimination. I'm actually going to try to do substitution for this one. So I'm going to substitute. I've got y isolated here. So I'm going to substitute all of this stuff in for y in my other equality. So what does that become? 4 times, and instead of y now I have negative 4x plus 8. Okay, so I've replaced this y with negative 4x plus 8. That equals negative 3x plus 24. All right, so I have negative 16x plus 32. That equals negative 3x plus 24. So I have to figure out a way to get my x's on the same side here. I'm going to add a 3x to both sides. Why am I doing that? Because now those guys are canceled, and I end up with a negative 13x plus 32 is equal to plus 24, positive 24. I can't even read my own handwriting here. What do I want to do next? Subtract that 32 from both sides. And what does that leave me with? Negative 13x is equal to 24 minus 32. What does that give us? So now that we know that x is 8 over 13, what are we going to do to figure out what y is? So we're going to have to do a little bit of solving. We're going to have to basically replace one of our x's in either this equality or this one with 8 over 13. I'm going to go with the first one because it's already isolated for y. So I have negative 4 times 8 over 13 plus 8. That gives me y is equal to negative 32 over 13 plus 8. And whenever we combine these here, gives us a 72 over 13. All right, so that's kind of a messy fraction there, and it would be okay if we converted into decimals. You guys know I like to try to be as precise as possible when possible. Let's go on to find another coordinate. So I picked the hardest one first. We're actually going to have a little bit of an easier time now. Let's go in alphabetical order and find the coordinate of my vertex B. Okay? So B is the intersection of y equals 1, that line y equals 1 here, and 4y is less than or equal to negative 3x plus 24. We would replace that with an equality. So 4y is equal to negative 3x plus 24. Well, this one's a little bit more straightforward. We can actually just substitute y equals 1 into my second equation here. So 4 times 1 is equal to negative 3x plus 24. I end up with 4. And I'm actually going to minus that 24 from both sides. Do a couple steps at once. So 4 minus 24. A billion announcements in the background here. So 4 minus 24, we end up with negative 20. It's equal to a negative 3x. And we divide both sides by a negative 3. And that gives us x is equal to 20 over 3. So that is my x-coordinate. It's 20 over 3. How do I solve for my y? Well, I actually already know that y equals 1. We see that up at the top. It's the equation of that line, so that makes things a little bit more simple. Let's move on and solve for c. And I'll do this one in black. So c is the intersection between a line y equals 1 and the line y is equal to negative 4x plus 8. So negative 4x plus 8, oops, y is equal to, let's try that again. Got a little bit distracted by all the announcements going on here. So c is the intersection between y is equal to negative 4x plus 8 and y equals 1. Again, same thing. I can actually just substitute 1 into this equation here. So I end up with 1 is equal to negative 4x plus 8. I'm going to minus an 8 from both sides. And I end up with negative 7 equals negative 4x. Divide both sides by a negative 4. And I end up with x is equal to 7 over 4. That's my x-coordinate for c. 7 over 4. Do I need to do any solving to figure out what y is? I don't actually, because y is equal to 1. That's what the equation of that boundary line is. So my three coordinates, a, b, and c. A is at 8 over 13 and 72 over 13. B is at 20 over 3 and 1. And C is at 7 over 4 and 1. Now we can see that it's not always going to be this complicated, so we're not always going to end up with such messy fractions. In fact, a lot of the time we'll be able to tell directly from our graph what the location of our vertices are. But in cases in which we don't, we might have one vertex that we need to find, and we need to be able to solve our system using algebra.